in this discussion a little bit more about various op-amp structures that we might see. Now, I'm assuming that when you've started this lecture, you've already heard about a few basic concepts. So basically what an inverting and a non-inverting configuration might look like. Because these are then two other configurations, particularly talking about with op-amps and resistors, that you'll see used again and again. And then from these techniques, you'll also see some dynamic circuits that are built around these concepts. So these turn out to be two really, really valuable ones. One is sort of a straightforward difference amplifier configuration that you see below. It's basically a very simple, conversation of I have now two inputs V1 and V2 going and an output of V out. Interesting circuit. Well, if I think about this almost from like a simple superposition perspective, what am I going to see? Well, if I look at it and I say, let V2 be 0, basically just grounding this voltage, I notice that I have an inverting amplifier, and I know what that solution is. I know precisely what that looks like in terms of V1. Great. Well, let me take a different case. Let me assume that V1 is now equal to 0. What circuit would I now see? Well, if I now sort of turn this one off, well, you're like, well, interesting kind of circuit. I see something that feels very much like a non-inverting configuration, but with a resistor divider in front. Well, I know what to do with a resistor divider. That's going to be, R1 and R2 underneath an R2, so that's going to be a term like this. And then I know the gain is going to be 1 plus R1 over R2. So interestingly enough, I get an R2 over R1 times V2 of T. You're like, wait, that looks almost identical except the different sign. And remember, I can do some device superposition by turning one voltage off, measuring and putting the other one in, and then turning that voltage off and then measuring the first based on the first one, and then just adding them up, because again, it is linear. So the net result is just add the two, and I get the output is R2 over R1 times the difference of those two, V2 and V1. So this is a very, very useful technique. And it's just important to kind of notice that what this is a resistor divider to handle the fact that I've got 1 plus R2 over R1 to kind of match that with the natural minus R2 over R1 with the inverting configuration. So this works out really well, and you say, great, what else can I build? Well, then you start to get this classical instrumentation amplifier. And if you look at it, you think, well, why would I want to do this versus this one? Well, again, notice that in this case, I've got V1 and V2 are both going into terminals of the op-amp, which means that it is completely isolated. So it also buffers whatever's going on from whatever I'm measuring to whatever the output is. Plus, it also gives me an opportunity with more resistors to have more gain stage. There's a few other things that can have to be important in terms of sort of getting an even better differencing structure, but basically this is a pretty typical and classical circuit that you'll see almost everywhere. So as a result, the first thing you notice is that the whole back end part of the circuit is this difference configuration. So we see it, we recognize it, and we go, well, I know what the answer to that is, so I don't need to rederive it. And in fact, if you think about it from the difference structure, I didn't rederive it either. Okay, I knew what the core structures were, I used superposition and solved it. And so this is the kind of things that you're often looking for. Then the question is, well, this whole front end circuit here is an interesting circuit, but notice it is a circuit with symmetry. That I have these two amplifiers, I've got two resistors, and I got a resistor here, but I can cut this in half. So that's going to be R3 over 2, and I got two of them in series, and that gives me a symmetric point. Well, if I look at that circuit is just simply a non-inverting amplifier circuit, now being looked at for the differential input, because for differences, the point of symmetry will be sitting at ground. That makes a fairly straightforward answer and a straightforward solution in terms of understanding what is the VA and VB as a function of V1 and V2. And it looks like exactly what you'd expect for the non-inverting configuration, assuming that this is actually cut in half. Okay, no surprise. So then I could just put the two things together, and then I can see the gain term. There's VB minus VA and V2 minus V1. times the term that is its gain term, which basically says I have a certain small amplitude and I make a big amplitude, or relative to the resistor size. And in this case, it's going to be this product R1 over R2 and 1 plus 2 R2 over R3. Again, there's not a lot of mystery to these circuits once you kind of can see it. And once you see it, it becomes pretty obvious. So it is really important to kind of just get comfortable with this and go, I see these as kind of core approaches, and that these are just kind of like part of you. And once you do that, it makes so much, the other part of the analysis is so much faster.